Hello and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe. We're back with another innovator interview, and we're going to be talking about the future of materials, particularly wood. You know, much of the building material of the future will be made from what we treat as waste today. And in a moment, we're going to talk with Forust co-founder Ronald Rael, who is the chair of architecture at the University of California, Berkeley's College of Environmental Design. He co-invented the Forust process, which is a way of making realistic grained wood using sawdust and lignin, which is a natural polymer found in wood. Forust is a subsidiary of Desktop Metal, a 3D metal and carbon fiber printing company. And Forust makes wood using 3D printing technology. The printed wood is surprisingly beautiful. It can mimic the natural grains and colors of different species, including rare rosewood, mahogany, and ebony that are the cause of widespread deforestation. And because it's printed, forest wood can be shaped for use in furniture and printed to service as structural supports in buildings. It opens up a whole spectrum of novel applications of wood in construction. So let's learn about what the company calls digitally-rematerialized-wood. Forust can be found at www.forust, and that's spelled Forust.com. Welcome to the show, Ronald. How are you today?
Doing well, Mitch. Thank you for having me.
Well, thank you for joining us. And first, printing wood. How does that work? Can you just break down very quickly how you make wood using a printer?
Sure. Well, the process begins with sawdust, and the machines that we use spread thin layers of sawdust down, much like a baker might spread flour over a surface. And then it sprays that wood with essentially water. Mm-hmm. And mixed with the wood is a glue. And when the water and the glue and the wood engage, it binds together to solidify that layer. Then subsequently, it lays down another layer and repeats the process over and over until a part is built, as we say. It actually grows from this process, and it's surrounded by raw sawdust. That sawdust is a support material that holds that in shape while it's drying. And then we pull that part out of the sawdust and blow off the excess sawdust, and all of that excess sawdust can be used again in the cycle. So there's no waste.
How do you get the graining, which is what, you think of printing as sort of uniform, but in this case, you're also articulating what looks like real wood grain?
Well, there's a couple of ways that we do that. And one is because wood is built, wood grows in layers, right? Mm-hmm. That we see growth rings every year because of the cycle of growth and water. And the additive manufacturing process also grows apart. And so there are actually layers that can be seen as a kind of synthetic grain in the wood. But we go one step further in that we can actually add colorant to that water to mimic the natural grain of wood as well. And so That's how we can begin to emulate different kinds of wood textures and grains. And we can go one step further than that. It's that because we can add colorant, and because that's based on images, we can add any image we'd like.
Oh, so you could print images into the wood. That's fascinating. And that's an interesting decorative component that I didn't get before this conversation. Mm-hmm. Now, obviously, there's plenty of sawdust in the world. We waste tremendous amounts of it. But what are the environmental benefits of forest wood? Is it less environmentally impactful to print wood than it is to go cut down a tree, for instance?
Well, if you imagine the timber industry cuts down trees, and of course that pulls out oxygen-producing plants from the environment, and then there's a tremendous amount of waste in that process. Mm-hmm. And so rather than take a tree and grind it up into sawdust or into smaller parts, we can begin with what is left over from that process, the sawdust, the millions of tons of waste that are produced each year by the construction industry, and use that to produce materials. And so there is fundamentally an efficiency in economy and ecology behind that, because one of the things that's done in the timber industry is that large old growth timber are used for construction. Mm-hmm. But we also envision a future where we are using small diameter timber for the use of producing wood products. And why that's important is because most of the forest fires, especially in California, are caused by an excess of small diameter timber in those forests. And it's a resource that can actually be used to improve the ecology of forests as well.
Doesn't sound like we'd ever run out of the raw materials of your process then.
No, I don't believe, not if we have healthy and sustainable management of our forests. And I think we have that in mind as a company, how we think about the sustainability and healthy ecology of our forests.
Now, the other question that I wanted to get to is the material itself recyclable at the end of life? You're using what appears to be entirely natural materials. Is there anything included that would prevent us from recycling that material and using it again?
We're actively working on that question. We're actively working on ways that we can take our products and recycle them again and use them back in the printing process. Of course, we can recycle our own product in the manufacturing process. As I mentioned, we can take that sawdust, build a part, and all the excess sawdust doesn't get thrown away. It's not a waste product. But we're actively thinking about and working on how we can take our products themselves and at the end of their lifespan, grind them back down and reintroduce them into our process to make more products.
Now, because the wood is grained like natural wood, you could sand it. It seems like you could make almost anything with this. Is there any application that you could not use this forest wood to do that currently we use wood to achieve?
Well, we see our products right now as being primarily for interiors, but we're also actively working on thinking about how they can be exterior products as well. Okay. And so we are currently limited in the size of our products that we can make, but we're also working on the problem of how to print much bigger products as well. And within that, we can certainly print components that can be put together to make larger objects. So just like furniture, which has, a table has its legs, its top, the connecting pieces, we can print those pieces to make larger products. And because two of the founders are architects, we're always thinking about how we can take components and turn them into something larger, like a building, like a spatial interiors, furniture, things like that. So it's
as an architect, do you see the opportunity increasing to use wood in applications that it's not traditionally applied in? For instance, buildings, as I mentioned earlier, but in furniture. But could we build cars or important components of cars out of this, as an example?
Yes, there's an interesting history of the use of wood in the production of automobiles, and the earliest automobiles were made out of wood.
Yes, they were.
We know of the charcoal briquettes that are made today from the brand Kingsford came from the Ford Motor Company, because that was the waste product of the automobile production. And so it's interesting to think about how cars still hold on to the memory of that in the wood grain interiors that are used in cars. Sometimes we see them on the gear shift or the dashboard. And so we see that our process is also applicable to automobiles, automobile interiors, components. We see it in the aeronautics industry as well, because we see how there are products that reference wood in those as well. And I think what's beautiful about that is that those are highly engineered products, automobiles and airplanes. And because our process has a certain degree of precision and complexity that is difficult to achieve with wood otherwise, we can now think about how we can manufacture components for automobiles and airplane interiors using the same kinds of three-dimensional technologies that are already used in those industries.
So could you engineer a forest wood to add capabilities by adding in a metal or other things to create additional flexibility or rigidity in the final product?
Well, that's one of the really great advantages of being part of the Desktop Metal ecosystem, that we can begin to think about how 3D printed metal and 3D printed wood can come together in elegant and beautiful and smart, intelligent ways. And so we can imagine how, I mentioned in the case of furniture or interiors, that wood and metal are always attached in specific ways. We can think about it in the simplest ways, like a metal screw coming to wood. But now we can imagine new ways of making connections. And because we're not limited by the shapes or forms that can be produced, because there's a limited number of tools for woodworking. For example, there are saws, there are blades, there are chisels, but now we have an entirely new tool for shaping wood. And that new tool has limitless possibilities in making shapes. And so shapes can offer new kinds of performances, that we can print air pockets into it for insulation. We can guide air through it. We can make shapes that are responsive to the body ergonomically. And we can also think about how metal and wood can fit together in really intelligent ways that maybe conceal or reveal or expose or hide or add performance value to the products that we make. And that's pretty, yeah.
That's fascinating. And the idea of an environment that is manufactured out of what we have treated as waste, and that is so much potentially more dynamic in terms of the quality and experience of the design that we create is amazing. Now, let me ask a couple. You mentioned woodworking, and I go here because my father is a very accomplished wood carver, and I've spent hours picking through wood samples looking for blocks he could work from. Is this a material that a wood carver could take and shape themselves, or is it really intended to be shaped in the printing process and then left as is?
Well, that's a really good question. I think there, in some capacities, it can be shaped. Certainly, it can be sanded. Certainly, it can be cut. I think that the kinds of post-manufactured processes for reshaping those products are going to be specific and tailored. And I think that's also an area of craft that is just open to be and yet to be explored. And also, I would think that's exciting as well.
Absolutely. Now, would the wood take a stain or a sealant just like a regular wood?
Yes, it does. And it does it in a really interesting way because the wood has a porosity to it. Mm-hmm. We do add a sealant and a stain to it, but it's much more absorptive to that sealant and stain, which gives it an incredible strength in some cases. And so we are now testing the structural capabilities of the wood. And in some cases, we're seeing that it performs better than wood in some structural instances.
Fascinating. So the sealant itself is contributing to the structure of the final product.
Yes.
Wow.
And we can color it in many ways that wood is stained, but it becomes much more integral and not just surface.
I was reading recently that the world's largest timber building is going up in Milwaukee. It's called the Ascent Tower. Could you design structural elements for an office or apartment building using your process?
Well, right now we are limited in size. Mm-hmm. The wood products have the capability they have structural strength, but we're limited again in terms of size. And so that building is so amazing because it is not only an innovation in technology and using sustainable materials, but it also becomes a way to think about sequestering carbon, right, which is an important topic, an important issue in our time today of environmental ecology. And our products do that same thing, right? Mm-hmm. Rather than the products being thrown in landfill, producing methane, releasing carbon dioxide into our atmosphere, being burned, we can now sequester that carbon within our products as well. And so I can imagine a future where there are structural buildings made out of heavy timber that are skyscrapers, filled with sustainable interiors that are made out of wood products as well, right, that are 3D printed.
Well, and you call out an important point, which is that currently we either burn or dispose of that sawdust in a lot of ways that end up contributing to global warming. Putting it in a building or in any object that's going to be there for 100 or 200 years, potentially longer, since we're talking about very durable materials, is a way of locking up that carbon and keeping it out of the atmosphere. And thinking in terms of constructing buildings as carbon sinks is an amazing way of rethinking the purpose of the building and extending its uses for society. Now, I know you're not doing this today, but do you think that you need to build portable large-scale printers to go on site to print something like that? Or is that something that you think needs to be printed at your locations and shipped around, which of course has its own environmental footprint too?
Right.
Have you thought through that problem?
We've been thinking about that problem for a number of years, and in some ways, we're working and engaging in that. I mean, we are, in some ways, the machines are portable, in fact, and they could be transported to different places. I think we are at the phase in our company where we are still doing some R&D, still perfecting our process, and therefore it's good to have a home base.
Right.
And to really flesh out some of these ideas. But I could imagine in some cases in the future where that product exists and all we do is take the machines to the product rather than bringing the product to the machines. I think we're open to those kind of concepts. And especially when the scale of manufacturing gets much larger, that certainly and definitely seems like an intelligent way of thinking about producing buildings or building components.
Well, and as you scale up the company, do you envision, will you sell the printers to others who will then put them to use, or do you develop printing centers? Because of course you would want to get this as close to your markets as possible. Do you have 10 printing centers around the United States, or do you sell to hundreds of customers that would use it to print materials?
Right, that's still a question that we're working on. We certainly want to expand the range of our services. And our technology, and so we're still working on what is the best way to grow and to allow others around the world to have access to this technology.
So one of the ways that you can access the technology today is to shop your store. You have these beautiful bowls that are designed and printed. It would be hard to carve your bowls. Let's just put it that way, and they're beautiful. So tell us about the Forust store. Are you going to be commissioning designs from different designers so that you have a wide range of decorative items, or where does the store go? What should we expect to see there?
I mean, we were really honored to work with the designer Yves Bahar, who designed those bowls, and we are actively working with other designers around the world, amazing designers who work with this technology and who are experts at 3D modeling. And I think this is another way we're thinking about growing, not only the possibility of growing, and I guess the question for me or for the company is, how do we allow others to access this technology? Because it's specialized in some way. In the same way, the tools and skills of your father were something that he learned over the course of many, many years in his lifetime, and it becomes a craft. Mm-hmm. And digital design is also a craft that designers learn over many, many years, especially in relationship to 3D printing. That's a whole other kind of craft. How do we allow anyone to have access to this technology? And so one way is through craft itself. And we are developing applications where anyone, a layperson not familiar with 3D modeling or 3D printing, can design something on their laptop in the cloud and be able to produce beautiful objects themselves.
That's incredible. So do you anticipate accepting designs from people, having contests for great design?
We do. I mean, we would very much love to work with architects and designers, and that we can manufacture their designs, their dreams, their aspirations for something that, and we can make that for them. And we also want to accept designs via the applications that we're working on by anyone to say, well, I have a wall of a certain dimension and I want to add these kind of features. And so we might have some presets or some ways that there's kind of digital tools that they can engage in very simple ways that allow them to produce the products. The products will be then delivered to them and they can assemble them themselves.
Like a template in a Word document in a way.
Yeah, exactly. A template in a Word document is a very good way to think about it.
Interesting. Well, Ronald, I want to thank you very much for taking the time to talk with us today. It's been a pleasure.
Thank you, Mitch. I appreciate it. I enjoyed that.
We've been talking with Ronald Rael. He is a co-founder of Forust. You can learn more about Forust at www.forust, and again, that's spelled Forust, www.forust.com. He's also the chair of the architecture department at the University of California, Berkeley's College of Environmental Design. And we encourage you to check out Forust and Ronald's work in general. This is a fascinating time, as I think I say every time I speak with you all. We're going to rethink how we combine different materials in our environment to reinvent our world. And Forust and this kind of engineered wood is an important step to rethinking the aesthetics of a lot of the different devices that we currently use. This is a material that could replace parts of our PCs or our laptops or our phones. And that's an opportunity to rediscover our relationship, not only with the technology, but the materials. I hope you'll take time to share this podcast and others from Sustainability in Your Ear with your friends and family. Let's spread these ideas. More ideas is going to lead to less waste and a more efficient economy. I'm Mitch Ratcliffe. We'll be back with another innovator interview soon. In the meantime, this is Sustainability in Your Ear, Earth911's podcast. We'll be back. In the meantime, take care of yourself, one another, and of course, this beautiful planet of ours. Have a green day.